Hey guys, welcome to Code Decode. Today in this video, we will be covering some Amdocs first round interview questions. Now, even from the personal experience and with the experience of few experienced people, I have found that some questions are common. They just love linked lists. So, the basic ones, the array, string, linked list, these are something you have to prepare for sure before appearing for Amdocs interviews. And secondly, they love Java 8 and they will hit you on your core concepts. So, keep your concepts clear, keep your basics clear, and then you will be able to clear the mdocs easily, but at times it becomes trickier. So prepare well, prepare java 8 some basic data structures really well. These are bound to be asked in the interviews. So let's get started and see some sample questions that were being asked. As discussed, the linked list questions are their favorite. So one of the questions that was being asked in the commonly in mdocs interviews is delete the kth node from the end. Now, what they're asking is you have a linked list with suppose five elements, five nodes. You have to delete the element from the last. Why is it tricky? Because it is easy to delete anything from start because you have a head pointing here. So this is your head pointer. Now, if I ask you delete the second element, what you will do? Go till the second element and delete the one. Then delete the third one, go till the third one from the starting, head dot next, and delete the one. This becomes easier, but they made it trickier by saying delete it from the last. So you have given a single linked list with n nodes. Your task is to remove kth node from the end. Now kth can be anything, so your code should be dynamic enough to delete the first node. This is fifth, second node, that is fourth, third, that is three, fourth node, and fifth node. So you can delete n number of nodes from the end. How will you do that? So you need to program which is dynamic enough to take a linked list and a number and delete that numbered node from the end. So let's do that. Let's create a new simple Java project for the linked list code named as Amdocs interview questions. Now, a very first thing we need to create is a linked list class. So a linked list class, what it has is a node. So we need a class node. Now here you can see this is a linked list with nodes. So we need to push nodes in the linked list to create it at the first place, right? Initially your head will be pointing to null. So what a node commonly has? A data and a pointer to next, a data and pointer to next, and so on. The last one is a data and pointer to null. So what we need is a int data and a pointer to next, which is again of type node. And we need a constructor to initialize the value. This dot data equals to data. And the next will be pointing to null. So this dot next will point to null. So with this our node class is ready. Now we need a main method to create a linked list and we need to push some data into this linked list. So we need a method public void push data and I'm going to pass the data that is to be created as a new node. Now what we can do is we can use this inner node class to get a new node with that data. So when you pass suppose linked list dot push say 1. So what we need to do is you need to first check if head equals to null. Now we need to create a head also here. So my node head will be pointing to null currently. So if head equals to null, then your new node only becomes the head. Head is null, then head is pointing to new node that you have recently created. But if that is not the case, for example, for when you push 1, your head is null. So your new node that you have created here becomes the first node. That is 1 will be your first node and head will be pointing to this. Next time when you try to push 2, then what will happen? Is your head null? No, your head is pointing to 1. Till now, with this line number 19, you have checked head was null. So you have pointing your new node. New node was created with this, a data and a next, which is next is null and data is 1 and head is pointing to this. Now when you try to push 2, you cannot move your head. The basic thing is head should always be pointing to the first node. Now it would have been easy if I had to put the first node here. So 2 pointing to 1 would have been easier. But now since we have to put 2 at the end, we need the new node here as 2. So what we need to do is you have to first create a node and then create a temp pointer here. So like this, we also need a temp pointer. And then till the temp dot next is not null, keep the temp moving and then point the new node as temp dot next and 2 dot next will be null automatic. So what we need to do is in the else condition, you need a while loop. But before getting the while loop, you need to create a temp node which is pointing to head and while temp dot next not equals to null, keep on moving temp ahead. Now when this is done, you know that your temp is the exact position after which you have to add the new element. That is, it is at the end of the linked list. Currently, since there is only one element, your head and temp is at same position. Now, since it is the last element also, the next element has to be added just after the head. But it will not be the case after 3, 4 and 5. Now the temp dot next should be new node and new node dot next should be null. So this is how you add an element at the end. So this was easy, comparatively easy. This is fine. Now 1 is pointing to 2, 2 is pointing to null. Now when you try to add 3 here, what will happen? Currently your head is here at 1. Is your head null? Answer says no. Then what you need to do? You need to create a temp pointing to head and go on till the next is not null. So temp will go from here to here. Now is the temp dot next null hai? Yes, it is null. Now what you need to do? It is, since it is null, now temp dot next becomes new node. So temp dot next becomes new node and new node dot next becomes null. So this is how you're going to create your linked list till end. So if this is clear, let's try to run this and see are we able to push 5 data into it. Now I need something to print. So I need one more method to print me. And it is going to take a head. Head will be of type node. You will be passing the head here and I'm keeping the local variable name as first. Now what we need to do, while we need a temp variable here who is pointing to first, that is to your head, and while temp not equals to null, go and print all the elements of temp, all the data of temp. So system.out.println temp.data and keep on moving ahead. Temp becomes temp dot next. So until you don't reach the end, keep on printing the data. And here, let's try to print with head. Let's try to run it. Since it is coming in the next line, let's remove ln and let's print in a space. Let's print with a space. So 1, 2, 3, 4, 5 is our linked list right now. Great. We are able to push the data and print it perfectly fine. Now I need an int n, which is the nth element from end to be deleted. So I say the second element is to be deleted in the 5 node list. So I need a method to remove kth element and I'm going to pass n and linked list. I'll be creating a method here, public. I'm going to return the head of the linked list that is finally created and the method name. Now the logic will go here, okay? So when you want to delete the second element from the last, so that is the fourth element from the beginning. So now this is the linked list 1, 2, 3, 4, 5 and expectation is remove this last second element. The last second element from the end becomes the fourth element from the beginning. So 5 is the first element, fourth is the second element from the end. Now it would have been easy if it would be having the second element from the starting. So what you would have done, you had taken a temp here and you have moved till the second element and deleted that by 1 pointing to 3 and 2 pointing to null. So 2 would be removed from the linked list completely. But now that is not the case. We have to delete from the end. So you can find the index from the first by deleting the total length minus the end element. It becomes the index from the first. So if you have 5 elements total in the list and you need to delete the last second, your n is the length of the list and 2 is the index that is to be deleted. So it becomes 3. So this is nothing but the index from the first. So 0, 1, 2 and 3. So if you calculate the total length and delete the n from it, it will be the exact index from the start and then you can easily put a temp here and go on till just before the index and then point 3 to 5 and in that case 4 will be removed. This is what we need to do, right? So let's first calculate the length. How do you calculate the length? So we can calculate the length while keeping temp from here and making it till go to null and then keep on updating the counter. So we can take int length equals to 0 initially since we have not calculated anything and also we need to keep a temp to the head of the list. So node temp equals to head and while your temp doesn't reach to null itself, keep on incrementing length plus plus and keep on moving temp to temp dot next. By this time you will have your length updated. Let's try printing the length first and let's see if this much works. So this was the linked list and this is the length. So we are perfectly finding the length as expected. Now what we need to do is we have the length, we have the index. Let's calculate the index from the start. So int index that is to be deleted from the start becomes this length minus n. So this will be 3 and now we need to go 0, 1 and 2. So the for loop will go from 0 to n index minus 1. For I, which is going from 0 to I less than index minus 1, reach just before the element that has to be deleted. And till then, you have to do temp equals to temp dot next. Before that, we need temp to head because we have already placed temp to null currently. So we need to again point temp to head and keep it moving till the next. As soon as your temp is at the right position, that is here, because we have given index minus 1. So it goes 0, 1 and 2. As soon as your temp comes here, your temp dot next should become temp dot next dot next. So temp dot next is 4. It should become temp dot next dot next. So 3 dot next becomes 5. Temp dot next should become temp dot next dot next. And then let's try to print the head. So we needed to delete the last second element. And can you see we have deleted the last second element. Let's try to delete last third element. That will become 1, 2, 4, 5. Let's try running it. 1, 2, 4, 5. Now we have to handle the corner cases. Now after this much is done, you are good to go with your program. But they will also work up with your corner cases. Now if you put a number which is equal to length, your code will not work properly. So if you try to run this, your code is not working properly. So how do you handle it? They give the n equals to length, then you have to remove the first element, right? In that case, you just need to move your head. So head becomes head dot next and return head. Simple. One more thing you need to do, since it is returning you a node, you need to take it in a node. And let me rename n to first, and now the first becomes this, and this is how you have removed the first element. So remember, they will also ask you what if I don't want to find the length? This particular loop is extra. I don't want to find the length. So, without length, how will you do that? So you can always use the slow and fast pointer. If you want to know how to do that, you have to let me know in the comment section, because I have many more questions for Amdocs to cover. So just let me know in the comment section. I'll create with fast pointer and a slow pointer a question for you. Now the next thing that they love is threads. So explain the life cycle of thread. The thread at any point of time exists in the following states: new, runnable, blocked, waiting, timed waiting, and terminated. New, when you have just created a thread t equals to new thread with a runnable. That is the time when your new thread is created. It is not ready to do anything. Now when you do t.start, it becomes in a runnable state. That is, it is ready for running or executing, but it is waiting for the resources or CPU to be allocated so that it can work upon. The next is blocked, when it is waiting to acquire a lock on something, or when it wants to re-enter to a synchronized block. So synchronized block is one thread at a time, so all the other threads that are trying to execute that method is waiting or blocked. Now wait for some other thread to perform some action without any time limit. So if you can say, you can use the object.wait or thread.join without any time limit. So until nobody comes and notifies it, it doesn't get out of the waiting state. Next is timed waiting. Waiting for some thread to perform some action for a specific period of time. That is, this is how you can give some time in milliseconds or nanoseconds to let the thread wait for that particular time only and then start executing again. Then terminated, when the thread has done its task, it will be terminated. So these are the life cycle of a thread. Now what is one more thing that they love is SQLs and databases. So what is the difference between the delete and the truncate? The delete is data manipulation language, while truncate is a data definition language. You must know the difference between both of them. This works upon the data, this works upon the structure. Now delete command is used to delete only specify rows. If not specified anything with a where clause, everything will be deleted in the terms of rows. While the truncate is used to delete all rows, and there is no chance for you to delete a specified number of rows from the table. So that is why there can be a where clause with delete command in order to filter the records. If where is not there, all the data or the rows will be removed. While there is no where clause in truncate, because it anyways will not going to filter your rows, it is not going to work upon your data. It is going to remove everything. It works page wise. So this works with rows, it works with the whole page of data. Now delete command is slower than truncate because it is performing deletion row by row. While truncate is faster because it operates on data pages instead of rows, as it deletes the entire table at once. Then it is allowed to restore the deleted data bit with rollbacks or commits, but it is not able to restore any deleted data after you have truncated your table. The delete statement occupies more space Then truncated because it has to keep the logs of each row deleted, while trunc occupies less space because it maintains the transaction log for the entire page instead of rows. One more important concept here, they will work upon your core logic. What is the difference between inversion of control and dependency injection? And where do you use qualifier, at the rate qualifier? So inversion of control and dependency injection are two different things. Though you can achieve inversion of control through dependency injection, but inversion control is a design principle. This is just a principle to help you invert the control of object creation. While dependency injection is a way to do that, and hence it is a design pattern. This is a pattern, that means it is a solution to implement this principle, which implements the IOC principle. So DI provides an object that an objects need. Let's say, for example, you have an employee class and it needs an address object or a bean. So rather than creating with a new keyword, the address class object, let's inject the dependency via constructor, setter, injection, and string. So that is dependency injection, injecting the required dependency rather than creating it on your own and making it tightly coupled. So this is a principle while this is a pattern. Now at the rate qualifier, again, it is a very important annotation that occurs when you use multiple implementations of an interface. So this is a situation to handle when you have created more than one bean for the same type and now you are trying to auto-wire the interface. So I'll give you a very good example of it. There is an interface animal. There is a two implementing classes, dog and cat. Both implements the animal interface. Now you have created a component. Great. Everything is fine till here. But when you try to auto-wire the interface, it fails. It says the animal requires single bean, but there were two beans found, that is cat and dog, because they both are implementing the interface. Now it is confused which eat method is to be called, from the dog or from the cat. So the solution to that becomes you use a qualifier with a cat. So you are stating that specifically with implementation has to be taken from the cat class for this animal interface. So that's the qualifier when you have two classes implementing the same interface and you are auto wiring an interface. The next is how ArrayList grows in size in Java. Now we know that ArrayList internally uses a dynamic array or resizable array for implementation. So since it is resizable, it has to increase when certain number of element has feeded into that particular ArrayList, right? It's not like an array. If I said it is 10, it is not going to take anything more than 10. It is an ArrayList which is dynamic, which is the advantage of ArrayList over array. It is dynamic in nature. So ArrayList is always created with a depth capacity of 10 if it is not provided with any constructor by the user. But it will not wait for all of your 10 elements to be filled and then create a new dynamic array and increase its size. What it will do is it will create a load factor threshold. So a threshold is calculated based on load factor and the current capacity, and when that threshold is reached, another new array list is created for you. Now what is load factor? The load factor is to decide after which the capacity has to be increased. So suppose a load factor is 0.75, that means after your 75% of your array list is filled up, after that you have to increase the size to 50% more of it. So suppose I have initial capacity of 10 and now I have a threshold of load factor into current capacity that is almost equal to 7. 0.75 into 10 becomes 7.5. So after reading the seventh element, the size will automatically increase to 50% of its original size. So 10 plus 5 becomes 15 and now the new array list will be created with 15 size and all the 7 elements that you have already added will be added to the new array list and the old will be discarded or garbage collected. So internally a new array list with a new capacity that is 15 is created and all the elements present in the old are copied to the new array list and old is garbage collected. So to summarize how it grows internally ArrayList uses the dynamic data structure, that is array, dynamic array, to work upon. When the array is full, you want to add new elements, a new ArrayList with a new capacity is created and all the data present in the old are copied to new while deleting the old ArrayList. That's how it internally works. Next, they always ask questions about design patterns. They love design patterns and you should know the basic design patterns for this question. So what is that design patterns and why they are really required, and do you use any such design pattern in your current project? So design patterns are generally reusable solutions to common problems. Now you have some common problem, to solve those comes the design pattern. And why they are introduced: to increase the speed of development and provide a well tested, performance wise better, proven development paradigms. It is not mandatory to implement the design pattern. So there can be a cases that in your project you have not used any design pattern. Why is that a possibility? Because there can be a case you have not faced any such common problem. So if you are facing a problem, then you will have a solution, right? If you do not have a problem, you will not go for the solution. You will not just implement a solution. So that is why there can be a case design pattern is not there in your project. Design patterns are not meant for your development. It is meant to solve the common problem. If problem is not there, design pattern is not there. But most of us do face such problems. Like for example, if you want to create a database connection, what we usually do, we create the instance of JDBC class and you call that class everywhere when we want to add or delete or something from the database. What will happen? You will be end up creating multiple connections to the database, each for one insert, each for one delete. You will open a new connection, and you know that database connections are limited. The pool is limited. Only limited number of connections you can create. So what you do is just to use one database connection for every insert, delete, update, get, what you do is you create the database class as singleton, so that in whole application you just use a single connection, and in this way you can control the load balancing and unnecessary connections to connect to the database in a connection pool. An important thing to remember, they will hit upon the core concept of Java 8. So I give you one very good example of it. I'm going to create a list, I'm going to stream, and I'm going to create a method. So let me show that how it was asked actually. Java 8 demo can work as a class name currently. Now what they have asked in interview is, you have created a main method, they have created a list of integers, and they have added some numbers. Now since your list is ready, I'm going to open a stream to it. Since stream works upon any collection class. Also I'm going to create a method print me. And this is a simple system.out.println. I am getting printed. Simple method, a very simple method, and that too static one. So when you open a stream, I just want to use a filter elements from the list, and while opening it I'm going to return true, because filter is always expecting some boolean to be returned here. This seems fine, right? Now can I just call this method print me? Can I do this? Simple. I have added a filter and I'm going to return true. So it is going to return true for every element, and hence every element will be processed and added to the new stream that is going to be created. So the new stream after this line should be having again the three elements, because filter is actually doing nothing here. It is just going to return true. But internal it is doing one more thing. It is not just returning true and allowing every element. It is also going to call a print method. So tell me how many times this get printed method will be called. Now let's try to dry run this. This filter is opening. The list element 1 comes here. It prints I am getting printed and returns 2. That means 1 is added to the new list. Then 2 comes here. It calls I am getting printed and returns true. That means 2 is also added to the new list. Then again 3 comes here. It calls I am getting printed and returns true. So 3 times I should get I am getting printed. So the output I would say is I am getting printed. But is that the real output of it? The answer is no. If you can see, output is completely empty. There is no output, because we forgot a one basic rule of Java 8. That is, filter is intermediate operation. There is no terminal operator added to this list operation, and we know that the intermediate operations are lazy loaded. That means you can put n number of intermediate operations. If you do not put one terminal operator like collect, which is a terminal operator, collectors dot to list, this is a terminal operator. Until you do not put a terminal operator to a list of stream, to the stream, till then this intermediate operator will not work at all, since it is lazy loaded. Now since you were getting an empty output here, I want to print it. I will add the terminal operator, and now let me run it. And let's see the output. Output is getting I am printed, I am printed, I am printed. So this could have happened earlier also if you would have added a terminal condition. So this is how they break you on your core logic of Java 8. you should understand that internally the intermediate operations are lazy loaded and they will not call or do anything until you do not put a terminal operator to it. So these were out of many questions asked in Amdocs. If you want to have the second round or more such type of questions, let me know in the comment section. Then only I'll create the next video for it. Thank you.